This lesson is the last lesson in Unit 2, Solving Rational Inequalities. Solving a rational inequality is very similar to solving an equation in that we will look for values of x. However, we need to consider that because this is an inequality, that there will be more than one value of x that could potentially satisfy this mathematical statement. So here on the right, I do have steps for us to take. We're going to find the critical points of our graph, which will occur at the zeros. We will also consider restricted values of x that do not appear in the domain. And we will test points to determine solution intervals. So let's begin with our first step, which is to find the critical points or the zeros of the graph. So let's solve this inequality first as if it were an equation. So we're going to take 4x divided by x minus 3 and set it equal to 6, solving for x. So multiplying both sides by the denominator, we have 4x equals 6x minus 18, which will give us that, 18 equals 2x, therefore x equals 9. So we know that we're going to have a critical point on the x-axis at 9. Now notice that our inequality has not only less than, but less than or equal to. So we know that at 9 we'll have a closed circle if this were a number line, and in interval notation that's represented by a bracket at 9. So we'll have to look at the fact that 9 is included in the solution. Now for step 2, we want to look at the denominator to see which values cannot be included in our domain. So if we set x minus 3 equal to 0, or really we say it cannot equal 0, then we know x can never equal 3. We have a vertical asymptote at x equal 3. Now because x can never equal 3, we're going to make an open circle on our number line and understand for the purposes of interval notation that these are represented by parentheses. We're almost there. Let's clean up this parentheses a little bit. So for our final step, we then want to test points to determine solution intervals. So you might remember this from solving polynomial inequalities. What we do is we set up a number line that represents the x-axis. And then we look at these points that we've determined, x equals 9, x equals 3, and we set those up on the number line as well. So I'll just space them out a little bit. You don't have to include every single value. We understand that we're supposed to have a closed circle on 9 according to what we wrote here. And an open circle on 3. So now we need to test points in areas that are less than 3, between 3 and 9, and greater than 9 in order to determine if we're going to get values that make our original statement true or false. If those values make our statement true, then we know that particular interval contains solutions. If the value makes our statement false, then we know that particular interval does not contain solutions. So here is our first test point. Let's test x equals 0, which is in the interval that is below 3. If I plug in 0 for x, I have 0 over negative 3 is less than or equal to 6. And of course that is a true statement. So what that lets me know is that all of the values that are below 3 will all be included in the solution. Next, I'll test a value between 3 and 9. I'll choose 6. You can choose whatever value you like as long as it is greater than 3 and less than 9. Do not choose 3. Do not choose 9. So if I substitute 6 in for x, I have 24 over 3 is less than or equal to 6. And that is not true because 24 divided by 3 is 8, which of course is greater than 6. So that lets me know that there are no solutions between 3 and 9. Lastly, I'll check a value that is greater than 9. I'll choose 12. Substituting 12 for x, I get a statement that says 48 over 9 is less than or equal to 6, which is true. 48 divided by 9 is 5 1/3, which of course is less than 6. So that lets me know that the interval above 9 also contains solutions. So how do I write my solution? Well, we're going to use interval notation. So the interval that goes from negative infinity up to 3, but not including 3, union with the interval that goes from 9 inclusive to infinity contains solutions. So this is our solution. Now if we look at this on the graph that I've given you, what we're really looking at is the graph of 4x divided by x minus 3 minus 6. So we can consider that to be y equals that particular function. And when we do that, we are looking for where y is less than or equal to 0. And from the graph, we can see that this happens as we come from negative infinity up to 3, which is our vertical asymptote. This entire section of the graph is below the x-axis, which means its y values are less than 0. And as we get on the other side of 3, we are greater than 0 or above the x-axis until we get to 9, where we equal 0, and then greater than 9, values of x greater than 9 lead to y values that are below 0. So graphically, you can see what's happening here as well. So if I had to put this on the graph, I'd have an open circle at 3, shaded to the left, a closed circle at 9, shaded to the right. You won't be using your graphing calculators for these problems, but I just wanted to show you graphically what the solutions represent. Okay, let's try another one here. Again, we begin by solving the inequality as if it were an equation. So this gives us x minus 5 equals 9x, which means that 8x will equal negative 5. X equals negative 5 over 8. So this is a 0 for us. We have restrictions in that 3x cannot equal 0, which means x cannot equal 0. Notice that we have a less than symbol without the equal to underneath, and so all circles will be open. Interval notation will contain all parentheses. So when we set up our number line, we have negative 5/8, and we have 0. Both are open. And then we want to do test points. Negative 5/8 is a little bit less than 1/2. So for the section below negative 5/8, I'll just choose negative 1. We would have a statement that says negative 6 over negative 3 is less than 3, which is true because 2 is less than 3. So I will have shading to the left of negative 5/8. In between negative 5/8 and 0 are all negative numbers that are greater than negative 5/8. So I will choose negative 0.5 or negative 1/2. Which will lead me to a statement that says negative 5.5 divided by negative 1.5 is less than 3. And 5.5 divided by 1.5 is actually 3 2/3, which is greater than 3. So I have no solutions in the middle interval. And then the last interval, values greater than 0, I'll choose 1. which will lead me to a statement that says negative 4 divided by 3 is less than 3, which is true. All negative numbers will be less than 3. So I will have solutions to the right of 0. And so my solution set will consist of values that come from negative infinity, go up to negative 5/8. I'll combine those with values just on the other side of 0 and continue to infinity. Notice the open parentheses denoting that neither negative 5/8 nor 0 can be solutions to this particular inequality. This video is getting a little long, so I'm going to cut this one as part 1 and then record a separate one as part 2. Stay tuned.